Got an assignment or a report to work on? What's the first thing you do? Open your laptop, start Googling, and within minutes, you're drowning in tabs, skimming through article after article, and still wondering, what's the actual answer here? Yeah, we've all been there. That's because today's tools either dump a bunch of info on you or give you vague summaries that don't really help you finish the job. But imagine this instead, an AI that understands your goals, plans the research for you, and gives you exactly what you need in the format you need it. That's where Agentic RAG comes in. Not just smart search, this is AI that collaborates. It reasons, decides, and helps you finish your work faster, better, and with way less stress. Hi everyone, I am Krishna Vamsi. Today, we are diving into the world of Agentic RAG, a major leap in how AI works with information. In this episode, we'll start by understanding what RAG is and why it's such a game changer in making AI smarter and accurate. I'll walk you through the three key steps of RAG: retrieve, augment, and generate, and explain how it helps AI give you up-to-date and relevant answers by pulling in real-time data. Next, we'll explore how RAG works under the hood, from how it organizes and processes data to how it generates answers for your questions. We'll also look at the common challenges RAG faces, like handling vague queries, blending information well, and personalizing responses. That leads us to the start of the show, Agentic RAG. We'll understand how Agentic RAG takes things a step further by adding smart reasoning, planning, and decision-making agents that collaborate to deliver exactly what you need in the format you want. Finally, we'll break down the workflow and components of Agentic RAG in detail and discuss why having these specialized agents matters so much. And it's not just theory. We'll also do a hands-on session so you can see Agentic RAG in action and get practical experience working with it. If you are curious about how AI can go from just answering questions to actually solving problems with you, you're in the right place. Let's break it down. But before we jump into Agentic RAG, let's take a moment to understand what regular RAG actually is. Because once you get how it works, the next part will make a lot more sense. So, what does RAG do? Let's say you want to know about the latest updates in IPL 2025. You open ChatGPT and type in the question. But how does it know what to say? That's where RAG comes in. RAG stands for Retrieval-Augmented Generation, and it works in 3 steps: retrieve, augment, generate. Now, let's understand these steps one by one. Step 1, retrieval. First, the AI searches through external sources like articles, research papers, or trusted databases to pull up relevant and accurate information about your topic. Think of it like asking a smart librarian to bring you the most useful pages for your topic. Step 2, augmentation. Next, the AI adds that information to your original question. It's like sticking all those useful facts right into its own notebook so it has more context when thinking about your question. So now, the AI not only has your prompt, it also has fresh, focused knowledge from outside sources. Step 3, generation. Finally, it uses that rich context to generate a response, a well-informed explanation or paragraph that actually answers your question, not just guesses. So instead of vague or outdated answers, you get something that's actually grounded in real information. That's the magic of RAG. It helps AI go beyond just pre-trained knowledge and gives real-time awareness by pulling in current and relevant data. So now we've seen what RAG means: retrieve, augment, and generate. But before we jump into Agentic RAG, let's first understand why RAG itself is such a big deal. To do that, let's compare what AI can do with RAG and without RAG. When you use normal AI, it mainly depends on what it has already learned during training. So if you ask about something new or very specific, it might just guess an answer or give a generic reply that doesn't really help. Unfortunately, LLMs can sometimes be a bit unpredictable in how they respond. One big reason for that is the way they are trained on a fixed set of data, which means they only know things up to a certain point in time. Some common challenges with LLMs include making up information when they don't actually know the answer, giving outdated or overly general responses when you are really looking for something current and specific. But with RAG, the AI goes and searches for real information from trusted sources while answering your question. Let's say you ask, which 4 teams have qualified to the IPL 2025 playoffs? Without RAG, AI might just say, based on IPL history, teams like CSK, MI, KKR, and SRH have qualified for the playoffs most frequently, so it's likely they have made it this time as well. With RAG, it actually could say, according to recent reports, Punjab Kings, RCB, Gujarat Titans, and Mumbai Indians have qualified to the IPL 2025 playoffs, with standout performances from key players. See the difference? One is vague and the other is clear and based on real info. That means you're getting answers that are more accurate and up to date. Another big plus is custom answers. Normally, I can't use your notes, files, or private data, so answers may feel generic. But with RAG, you can add your own material and the AI will include that in its response, so the answer feels more personal and useful for you. Here's a simple summary. Without RAG, answers might be old, general, or even wrong sometimes. With RAG, answers are based on real sources, more accurate, and fit your exact question better. So let's have a quick recap of what RAG is. Retrieval-Augmented Generation is a technique for enhancing the accuracy and reliability of generative AI models with information from specific and relevant data sources. So yeah, RAG makes AI way smarter. So far, we have seen why RAG is such a game changer. It gives us more accurate, relevant, and trustworthy answers, unlike traditional AI that just makes guesses from what it already knows. But now, let's go one step deeper and understand how does actually RAG work under the hood. What happens from the moment you ask a question to the point you get a smart, well-informed answer. Let's break it down step by step. Don't worry, we'll keep it simple. Behind the scenes, how RAG prepares the data. Before RAG can answer questions, it needs a solid foundation, kind of like organizing your study material before exam time. Here's how it works. Step 1, load. RAG starts by collecting information from many places, PDFs, websites, documents, etc. It's like gathering all your notes, textbooks, and screenshots into one single place. Step 2, split. Next, it breaks all the data into smaller, readable parts. Think of it like cutting a big pizza into slices so it's easier to eat. This way, RAG can fetch only the piece you need instead of serving you the whole pizza every time. Step 3, embed. Now comes the cool tech part. Each chunk is turned into a special mathematical format called a vector. This helps the system understand the meaning of the text, so it doesn't just look for exact words, but the actual idea behind them. Step 4, store. All these vectors are saved in something called a vector database. This is like a smart filing cabinet where everything is arranged so RAG can quickly find the most relevant info later. So now the data is ready. Next, let's see what happens when you actually ask a question. Let's say you ask, which 4 teams have qualified to the IPL 2025 playoffs? Here's what RAG does. Step 1, question input. RAG looks at your question carefully. It tries to understand exactly what you're asking, like a good tutor would. Step 2, retrieve. Then it searches for the most relevant pieces of information like articles, facts, or explanations related to your question. Step 3, prompt creation. RAG builds a custom prompt that includes your question plus all the helpful info it just found. This is like giving the AI a full context sheet before asking it to answer. Step 4, LLM, large language model. Now the LLM steps in. Using both your question and the retrieved content, it creates a detailed and meaningful answer. And finally, you got the response. One that isn't just pulled out of thin air, but built using verified info plus smart generation. Pretty neat, right? Now that we've understood what RAG is and how it works, we'll see how all of this comes together in action. Let's go. In this hands-on session, we are going to develop 3 different RAG applications. The first one is a RAG assistant that takes a file as an input and gives relevant answers. The second one is another RAG application that explains the code in a GitHub repository. The third one is a multi-agentic RAG application that uses tools like URL search, Google search, and answers relevant questions. To build these RAG applications, we'll use a tool called Langflow. Langflow is a low-code platform that helps us develop and deploy very powerful AI agents and workflows. So let's open Langflow. If you click on New Flow, we'll see 3 different options: basic prompting, vector store RAG, and simple agent. So to build this, we'll first start with vector store RAG. Once you have opened or created a new basic vector store RAG assistant, it will already give you the required default template. If you see this, there are so many different components which are just connected with the help of flows. So this is one flow and this is the other flow. All of these are different components which don't even require for you to write any code to develop these agents. So as discussed earlier, for a RAG assistant, you have 2 different flows. First one is data loading flow or data ingestion flow. Second one is a retriever flow. Let's first look at the load data flow. It has 4 different components. The first one is a file component, which accepts a file as an input. The second one is a split text component, which splits or breaks your file into small pieces called chunks. The third one is OpenAI embeddings component, which uses these chunks and uploads them to a vector database in terms of embeddings. The last one is an AstraDB component. It is a database or the vector database in which your file will be stored as vectors. Now I'll explain how you can add a file and finally store that file as chunks in this vector database. Now let's upload our file into this file component. So as discussed in the previous example, we'll use the IPL schedule as the database for it so that we can ask questions about the fixtures and different other facts about the IPL schedule of this year. Okay, so now this file is loaded into this component. We can leave this as it is. We don't need to change anything in the split text component. Now in the OpenAI embeddings component, you can paste your OpenAI API key. So I've stored it already in my global variables as OpenAI API key. So I'm just using it here. Now in the Astra DB, you have to select the database. So if you click on this option, you will see the list of available databases which are already created. If you don't have any, you can click on new database. You can give a name for this database. Let's use something like RAG Assistant database. I'll use a cloud provider as Amazon Web Services, and I'll select US East 2 as the region, and I'll click on create. So as I've clicked on create, this database which I have created just now is available in these options. So I'll click on this. So what it is telling is there's an unexpected error. So it means this component or it means this database is not yet ready. So to check the status of this database creation, you can click on this drop down and click on AstraDB. So here, if you see, my RAG Assistant database is still in the state of initializing. So we'll have to wait some time for this database to get created and for us to use. So once the database is created, we can create multiple collections inside it. Collection is nothing but a group of data that we can create inside a database. So for each of our use case, we'll create a different collection so that we can differentiate between different collections of data. So I'll try to create a collection and I'll name it as Personal Research Assistant Collection. So I'm not changing any of these fields and I'm clicking on create collection. So it will take a few seconds for the collection to create. Right, the collection got created. So you don't need to load any data manually here. Now let's go back to Langflow. So this is what we have created earlier. So we'll name it something to differentiate it among all the other flows or agents which we have already created. So I'll name it as Personal Research RAG Assistant. Right. So as now we are dealing with this load data flow. So in this file component, we have already loaded a file. Here, make sure this file is of less size, maybe less than an MB, so that you will not get any unexpected size limitation errors if you are specifically on a free trial. Here I have added this OpenAI API key, and here I have to select the database. As it takes some time for the database that we have created to get reflected in this, we'll select an existing database which I've already created and using previously. So I'll click on this test RAG flow, which is already created by me, and I'll select a collection which I've created. If you see, there are no records yet, so I'll load the records now. This is the file and everything is set. Now I simply have to run this flow. So if you see, this flow is running, it's built successfully. If you go and check this test RAG flow in the IPL schedule collection, now all of this data is just loaded. Simply let's go to the retriever flow. In the retriever flow, this is a chat input component where user can ask a question. Here a sample question which is given as what is the document about. Next, OpenAI embeddings component. So it can create embeddings as usual as you already know. This is AstraDB component, and here the embedding model is chosen as this OpenAI embeddings component. The embeddings which are created in this component will be given as input for this AstraDB. Now these results will go into a parser. This parser will parse the data frame or data and finally outputs the parsed text. Now here it's a prompt. This prompt usually has different options. There is a template, context, question. So in this template option, you can use any of the prompt which you want to give to this entire flow. Next, the output of this prompt component will go to the OpenAI component. Now this is OpenAI component, which is the actual LLM which takes in all of this as an input and finally results in well-structured, well-informed output. We again have to select the same database and same collection here. So test RAG flow, and the collection is IPL schedule collection. And in this prompt, so we'll edit this prompt. That's it. We'll update this prompt. Now what we shall do is we shall simply edit this. What do you know about IPL schedule 2025? Now let's run this retriever flow. I'm clicking on this and running this. So here the problem is there is no connection between this stage and the rest of this. So what we have to do is this prompt component needs a question. So we can just connect these two, and this context we shall get from the output of this database. So we'll connect this and this context. Now let's run this chat component again. If you see, every component from the starting is running in the sequence. Now OpenAI is running and it is transferring the response to the chat output component. If you want to see the response of each stages, you can check this bottom right corner of each stage so that you can see the response which is transferred to the next stage. If we say this OpenAI component, this is the response which it has given. The IPL 2025 schedule includes matches starting from March 22nd and features various teams such as RCB, etc., and all. This is all pulled out from the information which we have loaded in the vector database. Let's create one more vector store RAG. Before that, we'll go to the data stacks and create a new collection. This is for Github code explainer. So I've selected and created this collection. Right. Let's go here. If you see, you have a file component here. So instead of a file component, for this use case, we'll search for Git in the components, and we got a Git bundle. So we can add this, delete this file component, and use this Git component in the place of that file component. So here you can give the output from here as an input for the split text component. This component expects a repo URL. So we'll get a repo URL. It's a remote repo, and this is the clone URL. And I set the default branch as main. Now I have to select my database. I've selected test RAG flow again, and here I select GitHub code explainer as my collection. Right now, if I run this entire flow, so nice, this flow has completed. If we go to this GitHub code explainer and just try to reload this, this collection got some data added to it. Now that we have loaded the entire data, let's simply select the same database from here, testing RAG flow and GitHub code explainer collection, and in this context, let's change something. Let's Save this. The repository which I have given here is about a small project which is React pixel matching. It kind of takes two different images and matches them in terms of pixel matching and gives the results finally. Now let's run this flow. Let's see the output. Our question is, what is this repository about? It responded with this repository titled React Pixel Matching appears to be a React application designed for pixel matching. So it has explained everything which it knows about the repository. Let's ask one more question. What does app.js contain? Let's see the output. In this output, it explains what this app.js file contains. It has imports, it has React imports like use state, use effect, pixel match library, state management. It is also explaining the logic inside the component, promise handling, etc., etc. So great. So this is how you can create your own code explainer agent with the help of Langflow's vector store RAG assistant. Let's rename this as GitHub code explainer. Right. So until now we have built two different RAG assistants. So far we have seen how RAG system works, from preparing data to generating meaningful answers. But just like any smart tool, RAG has its own set of challenges, especially when used in real-world scenarios. While RAG is great at fetching and using external data, it can sometimes miss the deeper meaning of a question, especially if the query is vague. It doesn't always get the full context, which can lead to less helpful answers. Plus, relevance and accuracy are never guaranteed. If the system pulls in low quality or slightly off-topic data, it affects the final answer. These challenges show us one thing clearly. RAG systems need more than just retrieval and generation. They require smarter ways to understand context, make sense of information, think, plan, and respond like a real teammate. That's exactly where Agentic RAG comes to the rescue. It's built to take on these tricky areas by adding reasoning, planning, and even decision making into the mix. Let's now dive into Agentic RAG. Agentic RAG is an intelligent system that includes an agent, a smart decision maker. It not only pulls information, but also understands the structure of your question, choose the best database or resource, decides what kind of output is needed, like text, chart, list, timeline, etc. Plans how to deliver the final response in the most useful way. Let's use our IPL example again. You ask, which 4 teams have qualified to the IPL 2025 playoffs? And what are the fixtures for the playoffs? Here's how Agentic RAG handles it. User input and initial assessment. The system analyzes your question and realizes this is a 2-part query. You need the current standings and a structured timeline of key matches. Vector database selection. The agent analyzes the query type and chooses appropriate retrieval strategies. Vector search for semantic understanding of qualified, structured data queries for timeline information, potentially web search for the most recent updates. If the query does not match any database, the process routes to a fail-safe mechanism. Content retrieval. It retrieves detailed standings from DB1, a clear timeline of key matches from DB2. Response type selection. It figures out the best way to present the answer. A short paragraph explaining the current standings, a bullet timeline listing key matches. That's it. You get a well-organized response. Here it is. The top 4 teams that have qualified for the IPL 2025 playoffs are Punjab Kings, RCB, Gujarat Titans, and Mumbai Indians. And if, for some reason, the system doesn't find relevant info in any of the databases, it won't hallucinate. It will just say, sorry, I don't have any information you're looking for. That's the beauty of Agentic RAG. It's not just reactive, it's proactive. It makes smart choices behind the scenes so you get exactly what you need in the right format without any fluff. Now let's dive into the components and workflow of Agentic RAG. For a question like, explain the key moments in IPL 2024, here's how the system breaks it down and works step by step. Step 1. User input. You ask the system, explain the key moments in IPL 2024. Step 2. LLM Planner. The AI breaks this big question into smaller tasks arranged in order like Task 1. Highlight the opening match details. Task 2. Describe the standout player performances. Task 3. Summarize the playoff matches. Task 4. Explain the final match outcome. And Task 5. Put all key moments together to give a complete overview. Some tasks can happen at the same time if they don't depend on each other. But Task 5 waits for all the details to be ready. Step 3. Task Fetching Unit. This part figures out which tasks can start. It kicks off tasks 1 to 4 simultaneously since these are independent. After these are done, task 5 starts assembling the full answer. Step 4, executor. This unit runs the tasks using its tools. Search tool fetches accurate match info and player stats for each key moment. Synthesis tool combines these pieces into one smooth, easy to understand overview. Once all tasks are complete, you get a clear, full explanation of key moments in IPL 2024. With a clear understanding of how the different agents work together in executing tasks, it's important to recognize why having these specialized agents matters so much. Each plays a crucial role in making the whole system efficient and reliable. Why do these agents matter? By employing specialized agents with distinct functions, the RAG pipeline ensures accuracy, scalability, flexibility, and efficiency. Together, these agents empower RAG systems to deliver high quality, contextually accurate, and timely responses, no matter how complex the user's question might be. So, now that we have seen why these agents matter, let's quickly compare traditional RAG systems with Agentic RAG. They are quite different. Traditional RAG usually uses just one tool, a vector database, to fetch information. It works fine for simple lookups, but is limited to static documents. Agentic RAG is way more flexible. It can use many tools at once, like doing math, writing emails, analyzing data, or making decisions based on the situations. This makes it much smarter and capable. Plus, Agentic RAG is great at handling complex step-by-step problems because it knows which tool to use and when. It's also designed for teamwork with multiple AI agents working together to get better results. That's why Agentic RAG is a powerful choice for real-world, ever-changing tasks. Now let's go and build a multi-agentic flow with the help of simple agent. So here, let's delete this. So here there are two different components. One is URL and the other is agent. Agent is a component which connects with different tools like URL, search, Google search, etc. and responds accordingly to the question asked. So here by default an URL is added. So let's just delete this for now and let's ask a question to this agent. So in this instructions we can specify something. So by default it already has your helpful assistant that can use tools to answer questions and perform tasks. Okay, it already has OpenAI as a model provider. Let's ask some question. Who won the IPL 2025 match between GT and CSK in the league matches? It gave something like, I currently do not have access to real-time data or future events, including IPL 2025 match results. Right. We'll ask one more question. Who qualified for IPL 2025 playoff? Or which 4 teams have qualified for IPL 2025 playoffs? So the result is same. It doesn't have access to real-time data or future events. So let's do something. Here we'll add a URL component. So what this URL component is, it helps this agent to understand the URLs which are given and read that URLs, fetch the information from the URL and give the response based on the information it got from the URL. So let's ask the same question here. Which 4 teams have qualified for IPL 2025 playoffs? You can take reference from this URL. I'll just pull up CricBus URL so that it contains some information about that points table. Right, now we got the result. So the 4 teams that have qualified for IPL 2025 playoffs are Punjab Kings, RCB, Gujarat Titans and Mumbai Indians. We can see the execution of this agentic flow. So initially we have given the input and it has executed the URL fetch content because we have given this URL here. So it got this URL fetched and it got a response something like this. So from it has understood the response and gave the output. So now we have given this URL understanding support or URL understanding power to this agentic flow. Now let's do something. Now let's ask a different question which both the LLM and the URL which we are going to give doesn't know about. How much did Shubman Gill score in GT versus CSK match in IPL 2025? So the agent doesn't have the information. It has fetched this URL, and in the URL also it didn't have any information about this specific aspect. So what it responded is with, I couldn't find the specific score of Shubman Gill in this match from the available sources. You might want to check the latest updates on cricket specific websites like etc. etc. Now let's add one more powerful feature for this multi-agent flow. Let's search for search API in the components. Let's bring it here. So you need to add a search API key. So I already have search API key in this global variable, so it got automatically added. Now I'll enable the tool mode and attach this output to this agent's tools. Now you have added the search API for power also to this agent. Now let's ask the same question to this agent now. How much did Shubman Gill score in GT versus CSK match in IPL 2025? Right. So it has first executed this search component, fetch content. Now based on this search, it got some results and responded with the accurate information. In IPL 2025 match between GT and CSK, Shubman Gill scored 13 runs of 9 balls, including 1-4 and 1-6. Cool. So this is how you can create a multi-agent RAG assistant with the help of Langflow. So you can play with different components, different flows, mix up RAG and agentic capabilities and create your own assistants with the help of Langflow. So you can also click on this publish button and click on API access to use these APIs in your applications, or click on this embed into site option to embed this into your own applications. And that's a wrap on the wonderful world of Agentic RAG. Pretty cool, right? It's like giving AI a toolbox, a brain, and a little bit of street smart attitude. From searching info to solving complex problems with multiple agents working together, it's teamwork at a whole new level. This is just the tip of the iceberg when it comes to what's possible with AI today. And trust me, it's only getting crazier from here. So if your brain's doing a happy dance right now and you're curious for more, hit that like button, drop a comment, smash that subscribe, and don't forget to ring that bell icon so you never miss the next geeky but awesome deep dive. Before you go, please let us know in the comments what you would like us to explore next. We'll pick your idea for the next episode. Catch you in the next one.